All right, this is lesson 4. This is the last lesson, unit 10. Sorry about saying lesson 3. This is lesson 4. And what we are doing is we are taking, a region. Here's a region, and we're going to place objects on this region. So, like, you could place squares coming out of the region. You could place semicircles coming out of the region. And they're not just like squares, they're not two-dimensional objects, they're three-dimensional because it has a very skinny width. So what we're going to do is we're just going to take an infinite sum of the volumes of the objects but the volumes of the objects is just going to be like prisms. So it'll just be like the areas of the base. So the areas of the objects kind of faces, but then times the skinny width or height. The width is either going to be dx, the height would be dy, depending on the orientation, whether it's perpendicular to the x-axis. Perpendicular to the x-axis would be like this. So here, like, the width is dx. And then if I had like a different region, say like this, and I was using objects perpendicular to the y-axis, we'd say the height would be dy. And we'd just take whatever object we'd have the area of the object, multiply it by the width, multiply it by the height, becomes a volume. Okay, and of course, that infinite sum will be, either a top to bottom, bottom to a top, or a left to a right. An area formula based on a base length times dx or dy. Okay, so here is a region. We got x equals 4, we got y equals root x. I assume that I'm going to be using this value here, which is where they intersect, is at 2. And we're trying to find the volume of objects whose cross sections are perpendicular to the x-axis and are squares. So, like, perpendicular to the x-axis, that looks like this. Here's perpendicular to the x-axis, and I'm plopping squares down. Now, the area formula for a square is a side length squared. Well, here is my side length. My side length is this y distance. This y distance is just a y equals root x distance. So I'll take an infinite sum. Since it's perpendicular to x-axis, what's skinny about this is a skinny width. That gives us the three-dimensional quality of it. We're going from 0 to 4. We have a side length squared. That's my heights of my side lengths of my squares. And then times dx to give it volume. We want to do this without a calculator. We can. We'd simplify this first. This is just x from 0 to 4. Take the antiderivative, 1/2 x squared from 0 to 4. I get 8. Yep, minus 0. Okay, perpendicular to the y-axis that are squares. All right, so now I'm placing squares that are perpendicular to the y-axis. Here, here's my base length of the squares, and here's my squares popping up here. Here's my squares popping up here. Here's my squares popping up there. And we got to do the same thing. It's area of a square is a side length squared, but here's my side length. My side length is this width. The height, to give it three-dimensional, will be a small change in y. The width of this x distance. It's a right minus left distance. So the right is 4. The left is this x distance to this curve. Well, I'd have to turn this into x equals y squared. So I'm going to be going and summing these up from a bottom to a top to ensure dy is positive. And my side length is going to be 4 minus x squared squared. Now I ask you to do this without a calculator. What do you have to do? You're going to have to distribute. So 4 minus x squared squared is 16 minus 8x squared plus x to the 4th. You have to then take the antiderivative. Don't forget to take the antiderivative. I get 16x minus 8/3 x cubed plus 1/5 x to the 5th. From 0 to 2. It's going to be 32 minus 64/3 plus 32/5. you can leave it like this. This is fine for free response. Perpendicular to the x-axis, semicircles. Okay, so back to being perpendicular to the x-axis, but now I got semicircles. So here's what's tricky about semicircles. The formula for the volume, or the area of a semicircle, is pi r squared divided by 2. So 1/2 pi r squared. Pi r squared is the area of a circle. But the problem is the radius is not this entire base length. The radius is half the base length. Now there's two ways to handle this. You could either just take your infinite sum from 0 to 4 of 1/2 pi r is my base length divided by 2. So my base length is that root x divided by 2, and square that and give it some width. The width is dx. You can use this, and you could probably square things and actually do this without a calculator. Or you could say that the formula is 1/2 pi. The radius, you know, is the diameter divided by 2 squared. And if you square that, you get d squared over 4, or a simplified function, 1/8 pi d squared. So you could, instead of doing that, do this, 0 to 4, 1/8 pi d squared. And you find that, like, when you simplify this, you're going to get the same thing. It just already kind of squares the 2 to get the 4 and multiplies the 4 by the 1/2. So whatever. If you're going to do this without a calculator, it'd be, this would just turn into x, the antiderivative. I can pull out the 1/8 pi. The antiderivative of x is 1/2 x squared from 0 to 4. So that's going to be 1/8 pi times 8. So that's just pi. That's interesting. Okay. Perpendicular to the y-axis, rectangle's height is 3 times the base. Well, the area of this rectangle, area of a rectangle in general, is like a base times a height. In this case, I want a base times a height rather than like a width times a height. Length times width, it doesn't really matter. But the height, we are told, is 3 times the base. So this turns into base times 3 base, which is 3, the base length squared. So we're going perpendicular to the y-axis. That looks like this. The height is 3 times the base. Here's an expression for my base length. It is a x distance. It's a right minus left. There would be a very skinny height of dy, but that's just like going at the end. That has nothing to do with the heights of my rectangles. So it's like when I take my infinite sum, I just need dy here. It has nothing to do with the fact that this is the formula, 3 base lengths squared. So it's like 3 base lengths squared. I'll take an infinite sum. I'm going from 0 to 2. That's a bottom to a top. Bottom to a top. And then again, it's going to be 4 minus y squared. And that's going to be squared. You could do this without a calculator. Let's just, understand how to do things with a calculator. You don't have to take the antiderivative if you have a calculator. You just have to type in your integral. Just as you see it, your calculator will do a very advanced Riemann sum to give you a very good approximation, if not the actual value of this integral. $51.2. All right, moving to the same region. I think I was lazy on this homework, so I didn't change up the regions that much. Perpendicular to the y-axis. Okay, perpendicular y-axis. Here would be the bases of my isosceles rectangle, whose base is the same as the height. Sorry, isosceles triangle. Isosceles triangles, the area of a triangle is 1/2 base length times height. The base and the height is the same, so it's just 1/2 the base length squared. So I'm going to take an infinite sum of these 1/2 base length squareds. To give them volume, we'll say they have a very skinny width, making them kind of like a prism. Again, they intersect from at 4, 2, so an infinite sum is going to be from a bottom to a top. They have a skinny y. And then the base length is 4 minus y squared. Perpendicular to the y-axis. Wait, okay. Perpendicular to the y-axis, again, rectangles whose height is 2. Okay, so the area would be 1/2 base times height, but the height is 2, so it's just going to be the base. So 0 to 2, right minus left. That's it. Right is 4 minus y squared. Okay, and I probably would have you do this with a calculator, but be prepared to distribute. I probably would have you do this without a calculator. I'm not going to type this in the calculator. This, I'm going to take the antiderivative just for practice. 8 minus 8/3. You can leave it like that, but you can simplify it easily. It'd be 16/3. 24/3 minus 8/3. All right, new region. Now we need to be prepared to have this region without a calculator. You know, x squared and 3x. You got to figure out where they intersect with each other. I don't like to ever divide by x. You shouldn't divide by x because it'll eliminate a potential solution. But move everything onto one side factor. You get 0 and 3. And that makes sense. You can see it like here, 0, here 3. If this is 3, this is 9. So, all right. Perpendicular x-axis squares. So perpendicular x-axis squares. Here's the x-axis. Perpendicular would be this. These would be the base lengths of my squares. Here are my squares. The square's base length, and the area of a square is just a base length squared. So I need to take an infinite sum of these base lengths being squared. They have a very skinny width, very small change in x right here. I'm going from 0 to 3, that's a left to a right, but the base length is a top minus a bottom. Oh, I want you to do this without a calculator. All right, great. Let's see, we got 9x squared minus 3x cubed, which is minus 6x to the cubed. And then plus an x to the 4th. This is still an integral. Still haven't taken the antiderivative yet. The antiderivative would be 3x cubed. Maybe the numbers will work out. No, this is kind of cool. So 3x cubed minus, this is x to the 4th. This will be 6/4, which is 3/2. This is x to the 5th times 1/5. This is from 0 to 3. Ooh. Again, when you got a free response, you just have to show a unsimplified numerical answer, which is what I'm going to do. Yep. All right, perpendicular to the x-axis, y-axis squares. Okay, so perpendicular to the y-axis, changing it up. I'm going this way for my bases of my squares. Squares, the height is the same as the base. So, I mean, you don't even have to draw those pictures if you just realize, okay, same deal. Just going to be my base length squared. I did side squared for the earlier one. I think we're going to stick with base length being squared. I need to take an infinite sum of my base lengths squared. Now, to give this three-dimensionality, you got to multiply this area by a skinny height in this situation. It's a skinny height of dy. Now it's like a prism. the volume of a prism is just the area of the base times the height, or the width, depending, whatever. And we're going to sum these up from a bottom to a top to ensure dy is positive. My base lengths are going to be a right minus a left, but it's an x distance, so you need to solve equations for x, so you got x equals y equations. So this is x equals root y and x equals y over 3. That's my right minus my left, root y minus y minus 3. And you could, I guess, type this into your calculator. Why don't we do that? F9, 0, 9, root y. I need to put this in parentheses. Root y minus y over 3 squared. Looks like it's 2.7 even, and that my calculator just struggles a little bit with these square roots. Perpendicular to the x-axis semicircle. So again, with semicircles, two ways to handle it. You can either have 1/2 pi r squared or 1/8 pi d squared. Either way, you're going to get the right answer. I don't want us to have to memorize this, but rather understand how if you have d over 2, that's like a regular d, not a crazy d. That squared turns into d squared over 4, that 1/4, and then 1/2. So please don't memorize 1/8 d squared, or just understand where it comes from. So again, this is 3, this is 9. I will go and sum these up from 0 to 3. It's a left to a right. It's going to have a very skinny width to make it a volume. 1/2 pi r squared. The r is half of the d, half of the 3x minus x squared. I find that students struggle plugging all this into their calculator. I do think that the other method, the 1/8, is actually easier to plug in to your calculator. So I might recommend you use this. Just because it's easy to type in. .181 or 3.180. Perpendicular to the y-axis, rectangles whose base is half the height. Okay, so perpendicular to the y-axis, that rectangle's base is half the height. So let's get our area formula. Area of a rectangle is a base times the height, but the base length is half the height. This is tricky. If the base is half the height, and I plug this in for b, then I get 1/2 h squared, but I want something in terms of b, so I need 2b equals h, which means the area formula would be b times 2b. So the height is twice the base. It's just something to think about, making sure you understand we're talking about our base lengths being squared. Perpendicular to the y-axis, they'll have a skinny height. I'll go from 0 to 9. The base length will be the right minus the left. And you can type that into your calculator. Zero to 9, 2 parentheses root y minus y over 3 squared dy. 5.4. Okay, perpendicular x-axis or squares. This is tricky. Why is this tricky? Because I got these squares, and then I got these squares with different heights, and then I got these squares with different heights. So I need three integrals. I'm going to have an integral from this intersection, which is at x equals 1. This intersection is x equals 2. This intersection is x equals 3. This intersection is x equals 6. So let's go in the right color. 0 to 1. Squares, base length squared. Base length squared is x squared minus 1. Skinny width to make it 3 dimensions. Plus black 2 to 3. Base lengths are 4 minus 1, or just 3 squared. I should write 4 minus 1 so you know where it comes from. 3 comes from. Top minus bottom is the base length. Multiply by dx to give it volume, and then from 3 to 6, right minus left. Sorry, top minus bottom. You get that. Okay, and you type that into your calculator. I'm not going to bother doing that. Perpendicular to the y-axis semicircles. Well, if I'm perpendicular to the y-axis, yoink, 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 I can see the right and the left are consistent. Semicircles I can figure out. So area of a semicircle, 1/2 pi. The base length divided by 2 squared, or the diameter divided by 2 squared. Or 1/8 pi base length squared. I've been using d, but we know that the base length is the d. Okay, so infinite sum, 1/8 pi base length squared. Since perpendicular y-axis, it's got a skinny height to make it 3-dimensional. The base length, this distance from here to here, is a right minus a left. So I need to solve these equations for x. This is an easy one, x equals 7 minus y, but here x equals root y. So I'm going to have a 7 minus y minus root y. We're summing this up from a bottom to a top. The bottom is 1, the top is 4. That's 9, 1 to 4. I'm going to leave the pi out. So just to remind you that sometimes you can just incorporate the pi at the end, which might be required of you. So 3.745 pi. Why don't you keep it? Or multiply this by pi. 11.747. All right. This is a good one. This is from a free response question from last year, I think. Here's the region. We got the parabola and the cosine graph. You got to be able to understand which one's which. This is a calculator problem. Part B says region R is the base of the solid for each solid at each x. The cross-section perpendicular to the x-axis has an area, boom, of 1 over x plus 3. Find the volume of the solid. This might be a no calculator problem. So this is really interesting. Like, it's telling us the area. So, like, at an x value, that's the area. So it's like we don't know what the shape looks like, and this may seem like counterintuitive. You may think it's like, oh, I need some sort of top minus bottom here, but no, they're giving you the area formula. So I just need to take an infinite sum of this area formula and then multiply it by dx because it's perpendicular to the x-axis, going from 0 to 2, and that's it. I mean, if this was a calculator problem, you could do it. If this wasn't a calculator problem, you could also do this. Because you know the antiderivative of 1 over x plus 3 is log absolute x plus 3. And you plug it in 0 and 2, and you get log 5 minus log 3. Or log 5/3, because you know log rules. And that's it. So it kind of, they try to trick you up there, but don't get tricked up. Okay, S, cross sections perpendicular to the x-axis are squares. All right, so I got squares here. So area of a square is a side length or base length squared. So I'm going to take an infinite sum of base lengths being squared. I see that we're going to end at 2, but I don't know if this intersection is 1 or not. I'm going to put a 1 and a question mark. It might be something else. Don't assume anything. If you're not told what it is, don't assume it's at 1. I gotta do a little bit of legwork here. I gotta find that intersection. So let's go into your calculator, graph 1 plus x. I believe we did this for, previous homework when you were asked to find it, the area or something. Well, actually, I think we found the area of r plus s, so we used an absolute value, so we didn't care about that intersection, if I recall. But here I do need it. Make sure we are plugging in things carefully. I know I plugged in something wrong, right? Because this is not intersecting at 2, 4. So I'm going back. I'm checking. 1 plus x plus e to the x squared minus 2x. That's right. Yeah. That's so funny how I say, like, hey, make sure you plug in things carefully, and then I don't even plug in things carefully. There we go. So that's at 2, 4. Here's that intersection that they were talking about. You can kind of zoom in to see it a little bit better. Zoom in right at this intersection right here. And right there is what I'm talking about. Second calc, let's find that intersection. Is it at 1? No, it's not at 1. Don't get deceived. 1.0328319. 1.03, I gotta write that down. Don't assume. All right, so we're starting at this value. We're going to 2. The base lengths are a top minus the bottom. The top is the blue equation, that crazy e to the x equation. Here's the blue equation. You go up or down to kind of toggle between the two. Blue equation is the f equation. The bottom is the g equation. You're asked to find this actual volume, so you actually need to go back into the home screen, math 9 it, 1.0328319 to 2 of a quantity of f minus g, 1 plus x plus e to the x squared minus 2x. And then subtract the entire bottom. This is tricky to plug in. So I got to put parentheses around this entire bottom. Or when I subtract, I got to change all the symbols of this. So just be careful. I got x to the 4th minus 6.5x squared plus 6x plus 2. Close the parentheses for the g of x. Close the parentheses. Square that. That's going to be my volume of my squares times dx to make it a volume, 1.283. Perpendicular x-axis, isosceles right triangle, the leg in R. So here's my leg in R, here's my leg going up, here's my isosceles right triangle, like that, kind of like that. The area of this triangle is 1/2 my base times the height, but since the base and the height, it's isosceles, the base and the height are the same, so b equals h, so this would be 1/2 my base length squared. So I need to take an infinite sum of my 1/2 base length squared. We're starting at 0, but we have to go to this intersection here. I don't know what that intersection is. I have to find it. My base lengths are all top minus bottom distances. Top minus bottom. This y distance minus this y distance. So it's 4 minus f of x. And then let's find the intersection. When you do these problems like all at once, you don't have to find the intersection time after time after time. But it's good practice. I think this is the one that ends up being like at a 2.3 or something. It's like a perfectly nice decimal. Yeah, like right on the dot, 2.3. All right, and then they ask you to find the volume, so that means you got to type this into your calculator. Math 9, 0 to 2.3 of 1/2 my base lengths 4 minus, again, I'm subtracting this f, subtract the entire thing, x to the 4th minus 2.3 x cubed plus 4. That's subtracting the f. This is closing the parentheses, squaring that dx. 3.573 or 574. Okay, another perpendicular to the x-axis, but it's a square. Write an expression involving one or more integrals. Well, notice, if it's perpendicular to the x-axis, we're talking about using these vertical rectangles as base lengths. We see that the top and the bottom change. I do need 2 different integrals. My first integral is going to be from 1 to whatever this intersection is. I'm going to find it. It'll be a. As long as I list off what a is, then this is fine. And then I will add from a to, this ends up being at 5. My base lengths are going to be 5 minus x squared. So I have to do multiple. Let's find this intersection, log x at 5 minus x. .69. So as long as you write somewhere down what this is, you don't have to write it down multiple times. 3.69. .69344414. Okay, you do not have to evaluate. I don't know why I didn't write the log x. That's it. All right, perpendicular to the y-axis. Perpendicular to the y-axis, rectangle's height is 3 times its base. Rectangle's height is 3 times the base. Okay, so the area of this rectangle, base times height, but the height is 3 times the base, so this is going to be 3b squared. Okay, so I need to take an infinite sum of my 3b squareds, since it's perpendicular to the y-axis. My rectangles are going on top of those lines, those horizontal lines. To give them volume, we will multiply by a very skinny height, the dy. So 3b squared times dy is a volume. I'm going from a bottom to a top. This top is a y equals 6. So from 0 to 6. This base length is just going to my curve, but it's an x distance. This x distance, I need to take this equation and solve for x in terms of y, square it. I get x equals y squared over 4. Right, but do not evaluate. It's good to hear. Last question. Okay, the region has an area given by that. Find the volume of the solid. I bet you this is a no calculator. Pretty certain that this is a no calculator. And again, this is the expression for my area. So since they gave me an expression for my area, I just have to know that we go from 0 to 2 because it's perpendicular to the x-axis. But the area is going to be this. You don't have to do a top minus bottom. You're just saying, hey, based on an x-coordinate, this is the area. And then you have to take the antiderivative of sine of pi over 2x. It's going to be negative cosine pi over 2x. Don't forget a 2 over pi. That's the reciprocal of the coefficient. Since it's just x, we can do this. And we're taking antiderivatives, which is why we're taking the reciprocal rather than multiplying by the constant, which would be what you do if you take the derivative. Go from 0 to 2, I get negative 2 over pi cosine pi minus negative 2 over pi cosine 0. Be careful, these are values. Don't just assume it's 0. Cosine of pi is negative 1, so this is going to be negative 2 over pi. Positive 2 over pi because it's times negative 1. Cosine of 0 is positive 1, so this would be plus a positive 2 over pi. So that's 2 over pi plus 2 over pi is 4 over pi. That's it. All right, so hopefully we understand this. This is the last lesson. Test coming up soon.